From a group of 11 students, 3 must be chosen to meet with the headmaster. In how many different ways can the 3 students be chosen? So thinking about what we've seen previously, we might think we have 3 spaces. There are 11 ways we could select the first student, 10 ways we could select the second student, 9 ways we could select the third student, which is 11p3, or 11 times 10 times 9, which is 990. So there are 990 ways we could choose those 3 students. But this is incorrect. Or not fully correct, at least. So there are 990 ways we could select those 3 students in a particular order. There are 11 ways we could have chosen the first person, but once we've chosen them, there are 10 ways to choose the next person. That is saying that the order that we chose these 3 students matters. But in the context of this problem, it really doesn't. We're sending 3 people to meet the headmaster. It doesn't matter in which order we chose them. So to calculate the actual answer to this question, we need to take that 990 and we need to divide by the number of permutations of the 3 students that we chose. That is 3 factorial, which gives us a final answer of 165. Just to clarify, this is because ABC is the same as ACB, BAC, BCA, CAB, and CBA. All of these represent the same scenario in this particular case. If we chose A, B, and C as our 3 students, it doesn't matter which order we chose them. Any of these 6 orders would have been fine. We would have sent those 3 students. So that is why we're dividing by 3 factorial here, because 3 factorial represents the 6 ways of ordering the 3 people that we chose. Taking that idea and generalizing a little bit, if we have the case where we want to choose R objects from a group of N objects, where the order doesn't matter, that's what's important here, order doesn't matter. Let's write that down. Then we have, first of all, our permutation. Our permutation is n factorial over n minus r factorial. And so that's our permutation that we saw previously. But we also need to divide by the permutations of those r objects, which is r factorial. So we get this formula, n factorial over n minus r factorial times r factorial. And we actually have a special notation for this one as well. This is often denoted as NCR, N choose R. And sometimes this is even denoted as NR in what looks a little bit like a vector, but that is a different notation for meaning this. And this is what's known as a combination. A combination is when the order does not matter as opposed to a permutation. Now this particular formula is in the formula booklet, and you are expected to be able to do these calculations without a calculator. So referring back to some of the things we saw when we did simplifying factorials in a previous skill, you might have to do that in an exam question using this particular formula.